Alright, the next section of Unit 2 deals with factoring. We did a little bit of factoring in Unit 1, but that was more of the trinomials and just the quadratic formula. This time we're going to dive a little bit deeper into factoring. So I'm starting on page 16 in your foldable, and the first factor I'm going to look at is the easiest, the greatest common factor. Always, always, always check before you do any other method to see if you have a greatest common factor. So if you look at 10x squared y cubed and 15x y squared on page 16, the greatest common factor is 5x squared. Because they break it down into parts, into 10 and 15, the greatest factor between the two of those is 5. So that's where the 5 comes from. Then if you look at the x squared and the x, they both have an x in common. So there's your x term. Y cubed and y squared both have a y squared in common. So the greatest commonality between both of those things is 5xy squared. So if you look at the examples, 4x and 8y, if I break it down into numbers first and then variables, it makes it a little bit easier. So a 4 and an 8, they both have a 4 in common. If you're not sure how to find that, take the bigger number, divide it by the smaller number, and that'll tell you if that's your greatest common factor. So because I can divide 8 by 4, that tells me I get an even number. That tells me that 4 is my greatest common factor. Now I'm going to look at my variables. X and y have nothing in common. So my greatest common factor is 4. So now what I want to do is I want to take out a 4 from each of those parts. So essentially I'm just going to divide. That just leaves me with an x. Take out a 4 of the other one. That leaves me with a 2 and a y. If you get to the point where you're looking inside your parentheses and there's still something in common, that means you haven't taken out the greatest common factor. So you want to make sure you take out the greatest thing in common. All right, the second one, if I look at 10 and 15, I can't divide 15 by 10 and get a nice, pretty answer. But I can look at both of those and say, I can take a 5 out of them. All right, so there's my numbers are done. Okay. Now if I look at x squared and x, there is one x in common. Y cubed and y squared, they both have at least 2 y's in common. Now I'm going to just divide to simplify it out. I know that if I take 5 out of 10, that leaves me with 2, because 10 divided by 5 is 2. X squared over x leaves me with 1x. Y cubed over y squared leaves me with 1y. Alright, if I do the next one. $15 divided by 5 is 3. That's done. X over x cancels, and y squared over y squared cancel. Let's move that out of the way. So now, there's our greatest common factor. Alright, next page. Alright, 8 and 12. I can't divide the smaller one to the big one and get an even answer. So I'm going to look at something else. I know 8 and 12 can both be divided by 2. Is there something bigger? That's the next question I want to ask. Is there something bigger? Well, 8 and 12 can also be divided by 4. So that's my greatest common number. Then I also have an x squared and an x. So they have one x in common. And they both have a y in common. Alright, 8 divided by 4 leaves 2. X squared and x leaves 1x, and my y's will cancel. 12 divided by 4 is 3. X's cancel, y's cancel. Basically what I want to be able to do is if I took this out here and multiplied it back out, it should give me that. So factoring is just undoing multiplication. Alright, the next one. Right off, I see that I can take out a -4. And I'm going to go ahead and get the negative out for right there. Then I can take out an x and a y cubed. Alright, that's going to leave me with 6x, y cubes cancel, minus, because I'm dividing 16 by -4, x's cancel and I'm left with 1y. Now if you get to that point and you notice 6 and 4, I can still take something out, so that 4x, negative 4xy cubed is not my greatest common factor. So I'm going to take out a 2 from 6 and 4. So essentially, I've already taken out a 4, I'm going to take out 2 more. So basically, I'm taking out an 8, a negative 8 from both of them. So that will leave me with 2x. No, I'm sorry, that will leave me with 3x. Minus 2y. So basically, if I had looked at negative 24 and 16, I could have taken an 8 out of both of them. And 24 divided by 8 leaves me with 3. 16 divided by negative 8 leaves me with negative 2. So this one is my greatest common factor. Okay? 16 and 8, I know I can take out a negative 8. And I'm going to go ahead and deal with the negative and get that out of the way. Then I can take out an x, and I can take out one y, and they don't have any z's in common. So that leaves 2, xy go away, z squared minus 8's cancel, x's cancel, and I'm left with 1y. Okay? If you want to pause it, try these. These are a little bit bigger, but it still works the exact same way. Look for the GCF, take that out, so on and so forth. Alright, 4, 8, and 12, I can take a 4 out of all of them, and that's it. I have nothing else to take out of. Alright, so now x squared, 2x, and 3 have nothing in common, so 4 was my greatest common factor. Number 2, I can take out a 2, an x, and a y, which leaves me with 3x plus y squared minus 7x squared y. And if you look at what's left of that trinomial, there is nothing in common for all 3 of them. There is an x there, and there's an x squared there. So they have an x in common, but it's got to be all or nothing. That's why I don't take out another x. Okay. Number 3, I can take out an S7, an x, and a y. That leaves me with y squared minus 2x, because my y's cancel, plus 3x squared y. And again, there's nothing else in common for all 3 terms. Alright, number 4, the only thing that all 3 of those things have in common is a negative 3. There are no variables all alike to all 3 of them, just that negative 3. That leaves with x squared plus 3xy minus 2y. Okay? Now, if you look down at the bottom of page 17, the next kind of factoring is called the difference of 2 squares. The key word is difference. That means that I've got to have subtraction. You also have to remember that you always need to check for that greatest common factor. With every kind of factoring we're going to do, always check to see if you have the GCF for everything. Alright, the way these difference of squares work is you're going to have some subtraction and then a perfect square at the end. So you're going to be subtracting a perfect square. So if I take the square root of 9, that gave me 3, positive 3, and negative 3. So now all I have to do is write that in that form. Alright, so I'm going to break apart this, because there's 2. Each parenthesis gets an x. And I'm going to stick in a plus 3 and my minus 3. That would be the the greatest common factor, no, difference of squares for x squared minus 9. These are fairly simple. You just got to remember your perfect squares. Alright, x squared minus 25. I know that the square root of 25 is a plus and minus 5. I'm going to divide that in half. So each set of parentheses gets an x. So I'm going to have a plus 5 and a minus 5. Alright, y to the 4th minus 100 is a little bit different. But I know that 100 will give me plus and minus 10. But I still want to just take this and divide it evenly. So because it's 4, I can give each parenthesis a y squared. Then stick plus 10 check for that GCF first. If you look at 2y squared minus 32, 32 is not a perfect square. 2 is not a perfect square. So I want to check to see if I can take 2 out of both of them, and I can. So 2 leaves me with y squared minus 16. 16 is a perfect square. It can be broken up into plus and minus 4. So 2y plus 4 times y minus 4. Alright, the next one, I don't have a difference. If you notice right there, I don't have a difference. So I don't have a difference of squares. But I do have a greatest common factor. I can take out a negative 2 and an x from both of them. So that leaves me with x squared minus, which is what I needed, 162x divided by negative 2x is 81. Alright, now I've got my difference of squares. And when you're writing these, the GCF just goes in the very, very front. Okay? The next kind we've touched on when we solved quadratics in Unit 1, the X method, being able to factor these things. For now, I need you just to be able to factor them. When you plug them into the quadratic formula, it solves them for you. We don't have to take that step right now and solve them. I just need you to be able to identify factors. So to factor these, we're going to use the X method. We're going to figure out what multiplies to be 8 and what adds to be 6, which is 4 and 2. If both of your signs are positive, then your factors are both going to be positive. So x plus 4 and x plus 2. Okay? The next one, if you'll notice that both of your signs are negative, so I want to multiply to get negative 15 and add to get negative 2. Because the addition is negative, you get a negative answer, that means your biggest number is going to be negative. So I know that's going to give me a 5 and a 3. But I want them, when I add them, to give me negative 2, so that bigger number is going to be the negative. The bigger number takes the sign of the middle one. So my factors here are going to be x minus 5 and x plus 3. Alright, the next one is a little bit different just because it's got the fourths and the squares in it. Nothing changes. So I'm going to multiply to get 10 and add to get negative 7. Now in this case, when I added, I got a negative, but when I multiplied, I got a positive. So that means that both of my little terms are going to be negative. And in this case, negative 5 and negative 2. So now when I write it apart, I'm going to break that one apart in half. So x squared minus 5 and x squared minus 2. And get in the habit of when you have those x squareds, like right here, check to see if you have perfect squares, because then you also can factor it further into difference of squares. Since 5 and 2, neither one of them are perfect squares, you don't have to keep going with that one. Okay? Pause it, try your X methods for 1 through 6, then play it and check your work. Alright, when I factor number 1, I should have gotten x plus 7, b plus 7, equals b plus 1. I want to multiply to get 7, then add to get 8. Number 2, I want to multiply to get negative 90, and add to get 1. Remember, that's a 1 in front of that m. So you should have gotten m plus 10, m minus 9. 3, we're multiplying to get 9, adding to get the negative 10, so that means both of our signs are going to have to be negative. So n minus 9 and n minus 1. And you can always foil or box those back out to check your work. Number 4, we're going to multiply to get at negative 18 and add to get 3. So we're going to have p plus 6 because it takes the sign of that number right there. P minus 3. 5 and 6 are a little bit different just because of your leading degree is a little bit higher. So we're just going to break that apart in half. So this is going to be x squared minus 5 and x squared minus 10. So we're going to multiply to get positive 50, add to get negative 15. Okay? You notice this one is v to the 6th, so in half it would be v cubed. We're going to multiply to get 10, add to get negative 7. So v cubed minus 5 and v cubed check with those to see if you have that GCF. If not, you just go straight to your X method. But if you do have the GCF, like you will here, then you've got to add that step in there. So 2x squared plus 2x minus 4, 2, 2, and negative 4 all have a 2 in common. So if I take out a 2, that leaves me with x squared plus x minus 2. And then I want to see if I can factor that trinomial that's left. So we want to multiply to get negative 2 and add to get 1. I'm going to just bring my GCF down every time. So times negative 2, add to be 1. That gives us negative 1 and positive 2. So bring my GCF down, x minus 1, x plus 2. So the only step we've really added is just that GCF in there. Alright, next one, we take out a 4. And this one's going to work. We're going to bring the GCF down. Then we're going to try to multiply to get negative 2 and add to get negative 1. So that's going to be v minus 2, v plus 1. Alright, next one, 5, 30, and 40 all have 5 in common because I can divide 30 and 40 by the smallest one. X squared minus 6x plus 8. We're going to multiply to get 8, add to get negative 6. So that gives us 5 times x minus 4 and x minus 2, because we want to multiply to get a positive, but add to get a negative, so that means our signs need to be negative. Alright, if you want to pause it, try those 4, and then check your work. Alright, number 1, I'm going to take out a 3. And I'm going to multiply to get 8, add to get negative 6. Bring down my GCF. There's my answer. Alright, number 2, I can take out a 5. Factor to get multiply by negative 2, add to get negative 1. And because that's positive, my bigger number will take that sign, so plus 2 and minus 1. Alright, number 3, I've got a little bit different GCF. I don't have a number in common between 1, 7, and 10, but if you'll notice, they all have an x in common. So I can take out 1x squared plus 7x plus 10. X still comes down. And I want to multiply to get 10, add to get 7. So x plus 5